All right, so this is that second video in dihybrid crosses where we get to actually do this big Punnett square. And it may look a little overwhelming, but it's really not. I encourage you, if you want to tackle these dihybrid cross problems, take the template, the dihybrid grid that I've created, either print that out or copy it on your own on just a piece of paper. And that'll really help you do these problems and fill them in. So when I was saying about doing the FOIL method in my last video, here is an applied version of that FOIL method. Again, first, outside, inside, and last. So that first combination, capital R, capital Y, goes in this box. Capital R, lowercase y, goes in this box. Lowercase r, capital Y goes here. And lowercase r, lowercase y goes in that final box across the top. Along the side, because our other parent has the same genotype, capital R, capital Y, this box, capital R, lowercase y, this box, lowercase r, capital Y, this box, and then lowercase r, lowercase y in the final box. Now, I always like to highlight where the possible genotypes for my offspring are going to go. And ideally, if you've set this up, you can stop the video right now and try to fill it in on your own, and then check your offspring boxes with mine. So there's 16 boxes that you have to fill in. I try to keep myself organized by filling in across and then down. Notice I also keep the R's together and the Y's together. So take a minute, pause the video, whatever you have to do, fill in your dihybrid grid, keep your R's together and your Y's together, and then after that minute, join us. So once you have that dihybrid grid filled in, hopefully you've checked it to see if it looks like mine. We have to think about, okay, we've done this, but what does it all mean? So again, these are possible genotypes for the offspring, and each one of these possible genotypes is going to correspond to one of four combinations, essentially. So in our example, we have the possibilities of being round or wrinkled, yellow or green in terms of P's. So if we come up with all the different combinations, you could have round yellow. These are both dominant traits. So capital R, anything else, capital Y, anything else. Round green, capital R, anything else, lowercase y. You can have wrinkled yellow, which would be lowercase r, capital Y, anything else, or wrinkled and green, which would be lowercase r, lowercase y. So we want to go through all these offspring, and we want to check off, okay, which ones have at least one capital R and at least one capital Y. And we want to put a little slash or a little mark in those boxes. We want to do the same thing for capital R, anything else, and lowercase y. The same thing for lowercase r, capital Y, anything else. And the same thing for all lowercase. And once you go through and you do that, that is the analysis. And that is what makes this a really powerful and kind of cool tool in genetics. So if I scroll down here, I've already completed the analysis. And we see that there are 9, if you counted it up, and hopefully you maybe stopped the video and you did it on your own. You see that there are 1, 2, 3, 4, 5, 6, 7, 8, 9 out of a possible 16 that have at least one capital R and at least one capital Y. You see that there are 1, 2, 3 that have at least one capital R and 2 lowercase y's. We see that there are 1, 2, 3 with lowercase r, capital Y, and anything else. And last but not least, we see 1 out of 16 has lowercase r, lowercase y. I will be placing some optional problems associated with dihybrid crosses and these big Punnett squares for those of you that want a little bit of a challenge. And I will also post my answers, an answer key, so you can check yourself. All right. Thanks again so much, and I hope you're enjoying these cool, little challenging, but really cool genetics problems.